I'm a behavioral economist, which means we use data from adjacent social sciences about natural, meaning biological limits on how much people can compute and figure out, willpower and selfishness. And more recently, I've been interested in neuroeconomics, which is really just using neural evidence to think about economic decision making. But the neuroscientists are also interested in economic decisions as a model for normal human behavior and sometimes to understand abnormalities like sociopathy or autism. So it's a very mixed field of people doing neuroscience, including in med schools and psych departments, and a few of us interested in the economics. So a recent paper, which I think is very, very interesting and sort of illustrative, is about habit. So habit is something that a lot of sciences are interested in. There's a lot of practical interest, of course, in developing good habits like exercising more and restraining bad habits like overeating and addiction. And our approach to habit uses a neuroscientific basis, which means what habit is for is to save time when the activities you're choosing and you've been choosing repeatedly are known to be reliably rewarding. So the mark of habit is not, oh, this is really great, I have to do it again, but I know exactly what I'm getting. And I can kind of put my brain on autopilot. The other thing about habit that's very interesting is you can literally go from understanding, say, areas of the mouse brain, which are controlling either sort of mindless habit, doing the same thing over and over, and something more complicated we call goal-directed or deliberative. So the rat is faced with a new situation and they have to kind of figure out, how to navigate a maze or which button to press. And you can, for example, lesion areas of the rat's brain to either make them more habitual or not at all habitual. But you can also take kind of an elevator from the ground all the way up to complicated human behaviors, like what commutes people take and whether they give to charity in the same way year after year after year, not to mention the things like food, addiction, why do people forget to take their meds? So I think there's a chance that we'll be able to kind of have almost a scientifically unified concept of habit from animal brains, human brains, to things we can measure with sensors and apps and social media and so on. I went to grad school, a PhD school in what was then called the GSB, now the Booth School of Business in Chicago. And I wasn't in the hardest core areas of economics. I started studying finance, actually, and then kind of pivoted to studying human judgment. And I took some courses in economics. So I'm not a Chicago economist kind of by pedigree. But what I loved about the approach was it sort of combined, basic principles that are used sort of relentlessly, and as Gary Becker used to say, with like unapologetically or something like that, which is, people have an idea of what they like, they know that they're budget constrained, and they're optimizing in some way. So you can do some simple math and make predictions. And the way I think about Chicago in general is, at least the economics approach and the GSB and other places I'm familiar with, is people have these principles in mind. That's where this debate starts. And at Chicago, we like to argue, and we like to win arguments, and data win arguments, if you win at all. Sometimes it's hard to get the crucial data. And so the process of what I would call winning an argument, like the rise of behavioral economics, is on the order of decades, not an hour and a half debate and everyone claps louder for you. And it really is, the stereotype of Chicago economics is that it's all ideology. It's like a t-shirt, market's good, government's bad. And that's sort of the starting point of a lot of debate and a lot of how things are approached. But fundamentally, it's a place that's really interested in good ideas and empirics. And so I don't know if neuroscience will ever flourish here the way it is taking hold a little bit at Caltech, but most people in economics and certainly behavioral economics think, we need to know more about how people process information and what does a habit look like in the behavior and in the brain. And the key is to be open to other sources of data. And so there's a kind of closed-mindedness about the basic structure, like the starting point, but an open-mindedness about, wow, here's a cool experiment, or here's a new kind of data, or gee, the brain. And I think that's why Chicago will always be, a powerful institution, is that, it's always pushing forward with new ideas, new ideas, new ideas. So I think two things happening a little bit outside my own research interests. One is small, one is big. in terms of scale. One is called optogenetics, which is basically you inject a virus into brains, and the virus makes certain neurons light sensitive, and then you shine a light, and you can basically turn the neurons on and off like a light switch. And this is just magic. And the reason it's exciting is it's the best, newest tool to understand causality. So in economics, when we think about causality, we're often thinking about something like, well, some kids were born on August 30th and so on September 1st, and they go to school for different amounts of time because of this kind of natural experiment. And do they end up differently because of this tiny initial difference? That's sort of like a quasi-experiment or a natural experiment. Optogenetics is turning neurons on and off. And if we can turn the neurons on, and the animal does something unusual when we turn them off and it does something normal, we really know a lot about that process. So this is something we haven't done yet because you can't do it in humans. But I think it's an example of how there's incredible causal power to understand animal behavior, and humans are animals too, which another field has invented.